Suppose we wanted to solve the integral of cosine of x to the fourth plus 2 quantity times x cubed dx. Now, we can't do this with any basic integration techniques. We could certainly integrate x cubed by itself, and we could integrate cosine of x. But when you multiply these together, it gets more difficult, and you can't just take the integral of them separately and then multiply their integrals either. So it's not quite that simple, unfortunately. And while we can differentiate most functions, I mean, you got to be kind of a bizarre function or bizarre different points in a function for you not to be able to differentiate it, such as a jump or some kind of discontinuity or asymptote. However, with integration, there are actually a lot of functions that we're not able to integrate analytically. It's a bit harder to go the other direction. But thankfully, that's not the case in this situation. We can integrate this with a tool called U Substitution. Now, U Substitution is based on the chain rule. And if you recall back to differential calculus, the chain rule says that if we want to take the derivative of a function, or the derivative of f of u of x, that is equal to the derivative of the outside function times the derivative of the inside function u prime of x. So in words, on the left here we have the derivative of a function is going to be equal to the derivative of the outside function times the derivative of the inside function. So that was the chain rule. Now if we just take this this chain rule, if you're happy with that, we can move from there. We can just do a couple manipulations to the chain rule, and we can end up at the U substitution rule. So here we're taking that same equation up above, and let's say we multiply each side by dx. Now granted, dx does not have a distinctly tangible meaning. However, we are multiplying both sides by it, so we can do that. We can multiply both sides of an equation by something, and that equality is going to hold. So this is a valid move right here. And now the next thing we can do to both sides is integrate. Now this may catch you off guard a little bit. Could we just throw these integral signs in there? Well, you know you can add a quantity to both sides of a function, the equality holds. You can multiply both sides of an equation by something, the equality holds. You can divide. You can take both sides to a power. There's all kinds of operations that you can do to both sides of a function, and the equality holds, and integration is no exception. We can integrate both sides, and the equality is still valid. So from here, we can just take a look at that left side, and we can use the fundamental theorem of calculus part 1 to simplify that a bit. And the fundamental theorem of calculus part 1 says that if we're taking the integral of the derivative of a function, that integral is just going to sort of inverse that derivative process. So we're going to get right back to that function in the middle. The derivative and the integral are just kind of inverse each other. So based on that, we can find our U substitution rule here, which basically says if we take we take this left part of the equation on the upper left, and based on what we found over here, that's just going to be f of u of x, and that is going to be equal to this right side of the equation, the integral of f prime of u of x times u prime of x dx. Now let's see kind of how this works. So let's go back to this problem that we have, and then we have what we found for U substitution earlier, which is this equality here, just copying what we had from the previous slide. So this is kind of where we're starting with. Now here I just want to give you the answer. Hope it doesn't spoil the ending for anybody, but I just want to give you the answer to see how this U substitution rule plays out. So the answer here is our f of u of x, or the integral of our problem, is going to be 1/4 sine of x to the fourth plus 2. So let's go ahead and put that on the right side over here. That's our solution. So now we can kind of work backwards from here and see how this property holds. So if that's our f of u of x, we can just define our u of x first, which is in the middle of that sine function here. So u of x is going to be x to the fourth plus 2, and then we can find the derivative of this, or u prime of x, is just 4x cubed by the power rule. So now we can also define our f of u, which is 1/4 sine of u, because we defined u as above. And then we take the derivative of this, or f prime of u, it's 1/4 cosine of u, so basic derivative here. And now we can find f prime of u of x because we just plug in that u, which is x to the 4th plus 2. And now we can arrive at the left side of our equation up here on the right, which is going to be the integral of 1/4 cosine of x to the 4th plus 2 quantity times 4x cubed, which hopefully by now is looking pretty similar to our problem. But you can see where we got that from. Our f prime of u of x circled here went into the left side, and on the right side we had our u prime of x. So we're just matching up and just filling in for what's on the left side of the top equation up here. So you can see that if we just multiply this 4 and that 1/4, they're going to cancel out, and this integral right here is just going to be the integral of our problem, and we can see that our solution is 1/4 sine of x to the 4th plus 2. Now this is not how you use U substitution. I just wanted to show you how I just want to kind of connect the dots on here and specify what we're meaning by this f prime of u of x and u prime of x and f of u of x. And this isn't how we solve it, though, because if you want to try it like this, you have to know your answer first. You have to find an answer, and a lot of times you're not really sure exactly what that answer is. And there's actually a very methodical way to find this answer. Let's do that. I'm going to give you a step-by-step process to how you could come up with this answer here, 1/4 sine of quantity x to the 4th plus 2. So here's our problem. We got 7 steps. So first step we're going to do here is identify u. So a lot of times you may identify the wrong u, and that's all right. You just you may hit a brick wall. You just try a different u. But we're going to start off with the right u. The right u to pick here is u equals x to the 4th plus 2, because it's that. If you look at this integrand up here, it's the function within a function. So that's kind of where you want to start with for u. It's usually the function within another function. So next thing we want to do is differentiate u to find du dx. So this is a pretty easy one. Du dx is just 4x cubed. Now we actually want to solve for dx. So we can play around with the differentials a bit, and we can just say multiply. In this equation here, we can multiply both sides by dx. So we have du is 4x cubed times dx. And now we can solve for dx by dividing by 4x cubed. So we just end up with dx equals 1 over 4x cubed du. Alright, well now that we solve for u and dx, we can go ahead and substitute those back into our original integral. So here we solve for u. We're going to go ahead and plug that back in for x to the 4th plus 2 up here. We solve for dx down here. We're going to go ahead and plug that into our dx. And plugging those in, we end up with the integral of cosine of u times x cubed times 1 over 4x cubed times du. So this does look pretty ugly right now, and it may appear that we haven't really made any progress. However, we can go ahead and simplify this and factor out some constants. So we can see that x cubed is going to cancel out with the x cubed here. We can see we end up with a 1 over 4th that we can just bring it to the front. So now we end up with 1/4 times the integral of cosine of u du. And now we can see we've made some progress, because we started off with this complicated integral up here, and now we're down to this basic integral, and we've reduced a complicated integral down to a basic one that we can easily solve. And that's the whole point of U substitution, or any methods for integration. It's just always trying to break the integrand down into one of those basic rules that we can integrate. So next step is simply to use our common antiderivative to integrate this. And of course, the integral of cosine of u is just going to be sine of u. And finally, last step, but not least, don't want to forget this, is to go ahead and substitute back in for u. So our final answer is 1/4 sine of x to the 4th plus 2, which, as you recall from the previous slide, this was what the answer that we showed worked according to the U substitution equality. Now, when you get an answer like this, it's usually a good process to go ahead and check it. So let's do that. All right, here's our problem, and we're going to go ahead and check our answer. And our solution was f of x is 1/4 sine of x to the 4th plus 2. Now we can check it using the chain rule, because the U substitution came from the chain rule. U substitution just inverses the process. So to check it, we can apply the chain rule. So we want to find the derivative of f of x. and see if the derivative of f of x actually matches our integrand. If our derivative of our solution matches the integrand here, then we've checked our solution. Our solution's good. So f prime of x is going to equal df dx, just another way to say it. And according to the chain rule, that's going to be df du times du dx. So we need to define u again. So our u of x is going to be x to the fourth plus 2. Our f of u is going to be 1/4 sine of u. And now we got to solve for du dx, which is going to be 4x cubed. Our df du is going to be 1/4 cosine of u. And now we can go ahead and plug our df du and our du dx in for these differentials up here. And now we can go ahead and plug our u back in. And now we can go ahead and cancel out the constants there. So those 1/4 and the 4 cancel out. And finally we can go ahead and sub in u of x for u. So we end up with cosine of quantity x to the fourth plus 2 quantity times x cubed, which, as you can see, matches our integrand up here, so our answer checks out. So in conclusion, we have discussed the U substitution process. We kind of went over where it comes from, how it comes from the chain rule, and then we went over a 7-step methodical process in order to find a solution to an integral that lends itself to U substitution. And finally, we've shown here we're checking our answer, which is always a good thing to do if you want to be sure.